Let's take a few minutes now to look at how angles and circles relate to each other. There are 4 different places where you'll see an angle show up within the context of a circle. And the first situation, which you're already familiar with, is a central angle. And a central angle has its center, or its vertex, at the center of the circle. So here's an example of a central angle. And as you know from an earlier video, the measure of that angle will equal the measure of this arc. Another situation is called an inscribed angle. And in this situation, the vertex is on the circle. So I'm going to draw an angle whose vertex is on the circle right here. And this angle has a different relationship to this arc, and we'll see what that is in a moment. A third situation involves 2 chords intersecting randomly and not necessarily at the center of the circle. And in this situation, we can actually calculate this angle. And that angle of intersection involves knowing this arc measure as well as this arc measure. And this arc is intercepted by the vertical pair of the original angle. And then there's a fourth situation, and this involves 2 secants that intersect or meet outside a circle. And if we want to find what that angle measure is, then we will need to calculate or need to know this arc that the 2 secants intercept as well as that arc. And in the next 3 slides, I'll show you how to calculate an inscribed angle, how to calculate an interior angle measure, and also how to calculate an exterior angle measure. Let's first look at an inscribed angle. So I'm going to draw an inscribed angle by just drawing 2 chords that meet on the circle. And let's assume that this arc that the inscribed angle sweeps out is 100 degrees. And we're trying to find that angle. Well, it turns out that that angle is going to equal half of the arc. So an inscribed angle is equal to the measure of the arc divided by 2, which in this case is 50 degrees. So that angle is 50 degrees. And I want you to see why. So what I'm going to do now is draw 3 radii on this picture. So there's 1 radius, there's another radius, and here's a 3rd radius. And we know, since this is the center of the circle, that this angle is 100 degrees, which means that these 2 angles both have to be 130 degrees, so that collectively they all add up to 360. So this angle is 130 degrees, and this angle is 130 degrees. Now, we also know that this triangle is an isosceles triangle because it has 2 radii for 2 of its sides. So these 2 little angles right here are equal to each other. And these 2 angles, along with 130, have to add up to 180. So these 2 must be 50 together, so each of them is 25. So this angle is 25 degrees, and so is that angle. But the same thing's happening down in this triangle. So this angle down here is also 25 degrees. So as a result, these 2 angles together must be 50 degrees, which is what we saw earlier. So, in general, an inscribed angle equals half of the intercepted arc. Let's next look at an interior angle. And I'm going to draw 2 random chords inside this circle, and we're going to find this angle where they intersect. Now, I'm going to assign a couple of values to arcs. Let's assign to this arc a value of 80. Then let's assign to this arc a value of 24. And it turns out that the measure of that angle is going to equal the sum of those 2 arcs divided by 2. So in this case, that will be 104 divided by 2, which is 52 degrees. So this angle right here is 52 degrees. Its vertical pair is also 52 degrees. And we could even get the other two angles in here because they are linear pairs with 52. So this angle over here will be 128 degrees, and so will this angle right down here. The proof of this idea is a little more complicated than the previous one, so I think I'm going to save that to discuss in class at some point. But what I want you to take away from this is that for any angle that's formed by two chords, such as this angle right here, it's the average of the two arcs that that angle intercepts. So you add the two arcs and then divide by 2. The next situation is when we have two secants that intersect outside the circle. And if we want to find that angle, we are going to use the two arcs that the angle intercepts. This arc over here and that little arc over there. And I'm going to assign some values to the arcs. Let's say this one is 120 degrees, and this arc over here is, maybe we'll say 10 degrees. To get the measure of that angle outside, instead of adding the two arcs, we're going to subtract the two arcs and then divide by 2. So 120 divided, or minus 10 divided by 2 equals x. So x will be 110 divided by 2, so x is 55 degrees. One interesting extension of this idea is the case where we have two tangent lines meeting outside a circle. So I'm going to draw one tangent line and a second tangent line, and they meet outside the circle. And suppose we know that this angle out here is 40 degrees, and our task is to figure out the measure of that arc. So I'm going to call that arc x. Now we don't know its measure yet, and we also don't know the measure of the other arc, but we do know that this other arc must be 360 minus x. So I'm going to put that out here, 360 minus x. And now we can set up an equation. We know that an exterior angle, 40 degrees, is equal to the difference in the arcs, so 360 minus x, all over 2. And to solve this equation, we'll multiply both sides by 2, and I'll combine the x's. And then I'll move the 2x to this side, it becomes positive, and then I subtract 80 and I get 280. So x must be 140 degrees. So the measure of this arc over here is 140 degrees, and therefore the measure of the other arc must be 220 degrees. And we can check our work. If we take these two measurements and subtract, we get 80, and 80 divided by 2 is indeed 40.